everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous session, we have seen about file system implementation, what are the advantages of file system, what are the disadvantages of file system, and what are the issues caused by the file system. So, in this session, we are going to discuss about directory implementation. So, let us see the overview of this presentation. So, in this presentation, we are going to discuss about directory implementation and free space management and what do you mean by efficiency and performance of the file system. So, let us start with our directory implementation. So, in this directory implementation, the operating system can be done in the form of single linked list and hash table. So, here the directory implementation can be done in the form of single linked list. So, single linked list is nothing but the file which is mapping from one system to another system. So, file points to next file. So, this is how the directory implementation can be done using single list. So, points to other file. And using another one is using hash table. So, for this we are using some hash table with the value of key and value, key pair value. So, keys will be there, values will be there. This is attached to the hash table or hash function. So, based on this file system, based on this directory implementation, the operating system can be done by using single linked list and hash table. So, next one is the efficiency, reliability and performance of a file system are greatly affected by the section of directory allocation and directory management algorithm. So, in this directory allocation methods and directory management algorithms we have seen in previous sessions. So, there are numerous ways in which the directories can be implemented. So, there are n number of ways to implement the directories. But we need to choose an appropriate directory to implement the algorithm that enhance the performance of the system. So, whatever the directory which should be implemented, that should be in the proper and to enhance the performance of the system. So, to implement the perfect directory implementation algorithm, we are using this directory implementation methods. So, first we are going to see with single linked list and then we are going to see with the hash table. So, directory implementation with single linked list. So, directory implementation using singly linked list. So, in this implementation, the directories are singly linked list, easy to program but the time consuming to execute. So, easily we can implement or easily we can write or implement a program, but the time of execution will be more. Here we implement a directory by using linear list of file names with pointers and to the data blocks. So, we are using this linked list by using linear list is nothing but file names and with pointers to the data blocks. So, pointing to the next data file, nothing but pointing to the other data block number, nothing but pointer is nothing but addressing the next instruction. So, here file name, first how the directory implementation is used by single linked list. So, file name is added first, then pointers are pointers to data block. So, next it is going to next file, then again it is going to pointers to data block and it maps to again next file. So, this goes on by pointing to the data blocks. This is how it happens with the singly linked list. So, to create a new file, the entire list has to be checked such that no new directory does not exist previously. So, when the new file is formed, the existing file will be not performed well. So, the new directory does not exist previously. The new directory that can be added to the end of the list at the beginning of the list. So, the file can be added at the beginning or at the end. So, it may happen at any or else at the beginning or else at end. In order to delete a file, we first search the directory with the names of the file, then it should be deleted. So, whenever the unwanted files you doesn't want in your folder, then you will be deleted with some proper name. So and for XYZ file I don't want. So I need the XYZ file to be deleted. So then the XYZ I need to search that file, then type delete or enter delete. After searching we can delete. That file will be releases and give the space to new one. So after deleting we get the space and we can allocate the new files or new directories. To reuse the directory entry, we can mark that entry as unused or we can append it to the list of free directories. Append means added. So we can append 2 or more files when it is free for the directories. To delete a file linked list, it is the best choice and it takes less time. So to delete the file, this is the best choice and it takes less time consuming. This is how the directory implementation done with the singly linked list. Next we are going to see with the hash table. So directory implementation using hash table. An alternative data structure that can be used directly implementation is hash table. So for singly linked list we are going to check the delete the file, or we need to give the space for the new files, or we are going to entry for the new files at the beginning or ending. So here in this hash table, this is an alternative data structure that can be used for a directory implementation using this hash table. It is an overcome and the drawback of directory implementation using a single linked list. So it is one of the major drawback of the directory implementation by using this linked list. In this method, we use a hash table along with the linked list. So along with hash table, we are using this linked list. Hence, the linked list stores the directory entries, but a hash data structure is used the combination with the linked list. So in the previous session, we have mapping with single linked list to another file, whereas we are not taking any hash table or any other file values. By combining the linked list, we are taking one hash table, nothing but key and value of the file. So file name, pointers to data blocks, and one hash table with key value. Hash is hash function. Hash function is nothing but key. Values are nothing but files. So it is nothing but key value, key pair value. This is how the hash function works, key and value. So here we are taking one file name pointings to other data blocks and one hash table with key 1, key 2, so on, key n, and value 1, value 2. So this is going to map with file, and again this maps to next block. So pointing to the next block. So hash table is nothing but key pair value, hash function is key, values are nothing but files. So how this free space management can be done in the file system. So how we are going to free the space in the file systems. So free space management is a critical aspect of operating system as it involves and managing the available storage space on the disk or all secondary storage devices. So whatever the requirement of the files to get it free and to manage the data spacefully and to locate the secondary storage device to files, how we are going to free the space means removing or deleting the unwanted files and getting it free, or by using some other hard disk drives or any other secondary storage devices to store the files in a proper way. The operating system uses various techniques to manage free space and optimize the storage device. So operating system consists of various n number of techniques to manage the free space that can be optimized some using secondary storage devices. Here are some commonly used free space management techniques. So we are using some techniques to get it free. So what are the techniques? Linked allocation, contiguous allocation, indexed allocation, and file allocation table. So these are the 4 techniques we are going to use for this free space management in the file system. So let us see with the linked allocation. In this technique, each file is represented by a linked list or disk block. So in the previous session, we are mapping a single linked list. All the files are represented in the single list and it consists some block numbers. When a file is created, the operating system finds enough space on the disk and links the blocks of the files to form a chain. So whenever the file is created, the operating system finds some space and find the space on the disk and give the links to the blocks to form a chain. So when chain means nothing but path. So whenever you want to locate that file, so you can take that path and allocate that file. This method is simple to implement but can lead to fragmentation and wastage of space. Yes. So why? Because creating and deleting or wastage of the space may happen in this linked allocation. So what do you mean by contiguous allocation? In this technique, each file is stored as a contiguous block of free space. So why? Because until and unless the free space is not allocated to the files, wastage of the disk space. When the file is creating, the operating system finds a continuous block of free space and assigns it to the file. So until and unless repeatedly files are allocated, there is no free space. If the free space is happened, then the file can be assigned to that place. This method is efficient and it minimizes the fragmentation, but suffers from the problem of external fragmentation. So this may gets minimized of the fragmentation, but the problem arises at external fragmentation. This is what happened in the contiguous allocation. Next, indexed allocation. In this technique, a separate index block is used to store the addresses of all the disk blocks that make up a file. So based on the index block that can store the address of all the disk blocks and maintain some files. When a file is created, the operating system creates an index block and stores the address of the blocks in the file. So based on that index block only, it can store the address of so and so file that can be used for that file allocation or creation. This method is efficient in terms of storage space and minimizes the fragmentation. It is efficient for the storage space and it minimizes the fragmentation. This is how we are going to allocate the index in the file system. Next, how we are going to allocate the file allocation table. In this technique, the operating system uses a file allocation table to keep the track of location of each file on a disk. So whatever the files are created or you want to make the track of that files, that can be located in some location in the form of disk. When the file is created, the operating system updates the file allocation with some address of the disk block numbers. So it maintains some allocation table and that with that value we can find out that file is whether in that disk block or we can make the another file to implement in that file allocation table, or else it is already assigned. This method is widely used in Microsoft Windows operating system. So it is used in Windows operating system. That is what file allocation table. Next, what happens for the efficiency and performance of a file system? What do you mean by efficiency and what do you mean by performance of a file system? The efficient use of disk space depends heavily on the disk allocation and directory algorithms in use. So, the efficiency of the file system may be heavily allocated on the disk, or maybe it may be used by the directory algorithms. For instance, Unix inodes are pre-allocated in a volume. So, Unix inodes are pre-allocated to some volume. Even an empty disk has a percentage of its space to lost some inodes. So, in empty disk also it has some space loss due to the inodes. However, by pre-allocating the inodes and spreading them across the volume, we improve the file system's performance. So, by using or pre-allocating the inodes, we can spread the volume across the file system and improve its performance. This improves performance and results the Unix allocation to free space algorithms, and they try to free the data blocks near that file's inode block and to reduce the seek time. So seek time is nothing but reducing the or completing one allocation of the disk time. That is what about how the efficiency performed by this file system and how the performance is performed by this file system. So even after the basic file system algorithms have been selected, we can still improve the performance in several ways. So on the basis of file system algorithms also, we can still improve the performance in several ways. So once a seek is performed, the track is read into the disk cache starting at the sector and at the disk head, reducing the latency time. So we may have some latency time, disk time and seek time. So these are the three times which are used to efficient or improve its performance. The disk controller then transfers any sector request to the operating system. So it may transfer or the sector requests to another operating system also to control some disk space. So once block make it from the disk controller into the main memory, the operating system may cache the blocks into their buffers. So here the cache may be a buffer cache or page cache. Some systems maintain a separate section of main memory for a buffer cache, where blocks are kept under this assumption that will be used again shortly. Here the buffer is happening for the file or else the page cache may occur. So input output operation should be performed well until and unless the buffer and page cache can solve the problem by using this input output operations. Other systems cache file data using a page cache. So I said page cache and buffer cache can be solve this problem by input output buffer. So let us see these diagrams. So here input output without a unified buffer cache. So here file system is happening with the buffer cache and this buffer cache is happening with page cache, and page cache is mapped from memory input output. And here the input output are using read and write operations. So why? Because read and write operations to maintain the file system. So whereas here input output using a unified buffer cache, here we are not using a unified buffer cache, here we are using a unified buffer cache. So for file system we are taking one buffer cache and this memory is mapped with input output and we are using some read and write operations. This is how the happening is done with the unified buffer cache and without unified buffer cache. So this is what about the performance of the file system. So in this we have seen about directory implementation. And this directory implementation is using single linked list and hash table. And next next we have discussed about free space management in file system, how we are going to free the space in the file system. And next we have seen about efficiency and performance of a file system. So thank you.